Cool. Fine. So what I'm trying to explain, yeah, sure, I can zoom it. Is it fine now? Okay. So let me start the things what I'm trying to explain. Do let me know if you can see my screen. Okay, yeah. Okay. So basically, as so far, what are the things we have learned? We have learned couple of things. Like we have learned complete Python, we have learned complete stats, mathematics, machine learning concept, and also we have developed the project. Okay, and we know the deployment as far what I understood. But the thing is that in production it is not getting happen as expected what we did so far. Like in production there must be a some kind of pipeline, and pipeline in the sense of, let's suppose we have to do some kind of experiment. We cannot do from the scratch and we cannot start from the beginning itself, right? So every record, let's suppose in the company, let me start writing as well. Okay, so what I'm trying to say, let's suppose in your company there is 5 to 10 data scientists are there, 5 to 10 AI engineers are there. Every people will do their experiment, and some of the experiment will get success, some of the experiment will get fail as well. But the problem is I don't want to miss any of the experiment. I want to learn with the, because see, as a team everyone has to learn with the failure and success. What are the experiment we did or someone have been done, then what we learned with that experiment, what are the problem statement they solved and they didn't get, means they couldn't able to do that, right? So we should store all those information somewhere at the some stage so that anyone can go and they can check, okay, he did this experiment but this experiment got failed, she did something and this experiment got passed. So that's what we are going to define a ML system, like machine learning system or AI system, right? It's a happening for the like any kind of development field. In development also we are doing the something like we are establishing the pipeline. Okay, we have a database, we have a code base, we have a different kind of integration system. Let's suppose we have a Slack integration, we have WhatsApp integration, different kind of integration third party tools are there. But their problem statement and our problem statement is quite different. Don't be confused with the others development and this development is something like we cannot expect what the result will come. But if we are going to do the kind of hard coded development, let's suppose if we are developing something like, okay, integrate the WhatsApp, we know if we are going to use some certain library, the things will happen. But here is something like result is not expected, right? So always we have to, we can, means any product, neither product manager or nor your team lead is going to give you the tentative deadline. So within this deadline you have to finish. Okay, so no one is going to give. That's a benefit of the AI, because if it is a good AI engineer, they know like what the challenges might be occur. It can be possible like within a day we can achieve our goal, but it can be possible we are spending a month but we are not getting the result, right? So always we have to take a, means we cannot set any kind of deadline, to be honest, but we'll try to achieve our goal. So in order to do see these kind of fluctuations and fractional result outcoming coming in the differ of the different at the different stages of the time, we have to show, okay, you cannot take, okay, I am doing this experiment but I am getting failed, you cannot say like this. But you have to show, okay, I did this kind of experiment and at the different stages you can see, like I spend my half an hour, 1 hour, and I did this experiment, but afterwards it result is something which is not expected. Then anyone can go in the dashboard and they can see, yeah, literally you did something but the result is not expected. Then they can allow you to go further and further deep dive into the problem. So the see, the benefit of using this system is there are multiple benefits are there. Number one, as a senior data scientist, as a senior AI engineer, with by seeing the result, they can easily understand whether you are striking the right goal or not. That's the one thing. But let's suppose you 1 month you tried, but still we didn't reach to our goal. That's also might be possible. So everyday report, if anyone, if the team is going to see, they can understand, they can predict whether we are striking the right goal or not. That's the one thing. Okay, so that's what always we have to build a pipeline is always important here. Second benefit, so pipeline building, first benefit is that collaborative action can be performed. Collaborative action can be performed. Second, iterations of the different experiment can be performed. Let's suppose you did your experiment and same problem statement I want to solve. So I don't want to start from the scratch. I will use your pipeline. I can start working from there. So result can be stored as somewhere. So what we can do, like different iterations of different iterations of different iterations of execution can be performed. Okay. Okay. So third benefit is there. Okay. So third benefit is basically, see, your complete infrastructure should be moved into the production. Whatever you think you are doing in your local system, that has to be ideally how the things. See, some people recommend these things, some people deny as well. Some people want everything to do the setup in the production or in the cloud, and they can take a, right now different tools are coming with which you can directly do the coding in the cloud. That's also possible. Okay, that's in this era, it's everything is possible. But some people want everything to do the setup in their local set. I don't know why, but some people used to. But I don't like this kind of way. I always used to be independent working, like make a setup at one place and use by many people, like whatever teammates want to use. Because if I'll do the setup in my system, it will be only applicable for me. But if I'll do the setup in my cloud, and anyone can access this setup, right? So I always believe these things. So make an infrastructure, make your infrastructure ready for your teammates. Okay, that's the one thing. Okay, fourth, so we can deploy our CI/CD pipeline. What is CI/CD pipeline? I'll explain in later on. Okay, this is the benefit of the deploying like ML system, and ML system different from the software system. Why? Like that's a complete more about the R&D, research and development, But if you'll see the other software system, the developers are doing, like, it's not about the R&D, it's about the integration and deploying. That's all. They know if we are going to add 2 plus 2, we'll get a result equal to 4. But here it's not like that. It's a complete neural network, it's complete machine learning algorithms is there. We don't expect, like, if we are going to add 2 plus 2, the result will be 4, right? That's a one hunch I can say. Okay, now coming to the part of coming to the part of another thing, what I'm trying to say, just let me explain this part. So in our case, machine learning system is like continuous training. It's not like that we develop something, we develop some feature, we deploy into the production, and it will go for the long run. It's always be like we develop one model, it should be always be a continuous training. Means, see, let's suppose you trained with some kind of machine learning algorithm and you went into the job, and you are job ready guy, like, so you start working around that. But after 1 month or 1 year, some new algorithm came and some new research came, and you have to be keep on training yourself so that you can be in line with the market demand, right? So similar kind of things is here as well. If you are train your model, and if you are thinking that your model will be give the same result whole life, then it is not going to be happen. So there is a one difference between the ML system and other software system, like, so let me put in the slide as well, just a minute. So what I'm trying to say, just a minute, it's a continuous training process. Okay, so it's a noble attribute specific to the machine learning system that deals with the automated retraining system serving the model. That we have to develop. That's what we are going to build a complete pipeline, right? pipeline in the sense of, if we are going to deploy our pipeline, it should do like continuous retraining. Let's suppose automatically you understood, you feel like, okay, now the new technology came into the markets, and then again I have to reach to some trainer, and I have to keep on training myself, start training myself, so that I can be in line with the market demand. So we have to deploy our pipeline such a way so that the model training should be triggered automatically. That's a hunch we are going to do here. Okay, so next different point is, what is that? Continuous deployment as well. Like once the training has been done, let's suppose you train your model. That can be possible. Two things here, the two thing might be possible. You train your model, this is your machine learning model, and earlier the model 1 was there in the production, M1, and this is the M2. Okay, now it can be possible M2 can perform the better than the M1, or it can be possible like M2 is the worse than the M1. So we should have some kind of evaluation metric to evaluate the M1 and M2. Okay, so if you guys ever gone to the casino, in casino, what we have seen, if you have seen like trading wind, right? How the things is going to work in the trading wind, right? So in trading wind, what is this getting happen? There's a circle is moving, right? So let's suppose how they are going to do the balancing. So here is some kind of levers are there associating with all the machine, and what is getting happen. So whenever the load is getting over for the particular machine, the lever is measuring, and the lever is directly moving these loads, whatever incoming loads is moving towards the another machine. Similar kind of thing is happening here, where as soon as load is reaching to the threshold of the second machine, then it is moving to the third machine, and vice versa is getting happen. So similar kind of thing we have to deploy here as well, whenever we are going to approach a kind of continuous training process. Whenever we are going to do these things, active learning, this term is called as active learning. So what we are going to do, whenever we are going to deploy our M1 and M2, so we have to continuous watching, we have to continuous our monitoring the M1 and M2 both, what was the previous model and what is the newer model, right? So what we can do, like we can pass the traffic first to the M1, and we'll see the result of M1, and simultaneously we will pass the result of same load we will pass to the M2, and we'll see the result, and we will check, okay, M1 is performing better or M2 is performing better. If M2 is performing better, then we can switch from M1 to M2. This logic we have to write. Don't worry at all about these logics at all. We will work around this. We will think around that how we can switch our model. So does it make sense? Any questions so far? Like what we are trying to do? So as soon as your model deployment will be done, we have to do this much of thing. Okay. Yeah. Now let me show you what are the basic steps we have to perform whenever we are going to deal with machine learning problem. So let me show you. Okay. These are the very basic steps that we have to perform. First, generic step in the AI and ML system. First one is data extraction that we are going to do. Data preparations, then data extraction, data analysis. Third, data preparation. Fourth, model training. Fifth, model evaluation. Sixth, model validation. Seventh, model serving. And eight, model monitoring. That I already told. These are the life cycle of any kind of machine learning model that we have to follow, and then only we can reach our goal, right? Any question in this execution life cycle of machine learning? No question? If you have any question, yes, you can. Yeah. Data extraction in the sense of, okay, let me explain this part. Data extraction, what is the data extraction? So data extraction can be done by the various way. This is the important role where the developers are coming into the picture. They will extract the data for you. That's a primary demand as a data scientist from the developer or as a product manager or to the product manager. So whenever data scientists start working, their job is not to extract the data, but yeah, if you are working as a startup, if you are working as a very startup culture, if you are working on your own project, then you should know how to extract the data. Means Extraction in the sense of, let's suppose if we are going to open the Flipkart page. Okay, in the Flipkart page, whenever we are going to, have you worked on this like what we call review scrapper project, right? In the review scrapper project, what we did, like we passed the iPhone, and in the iPhone, whatever reviews people put on the Flipkart website, we used to scrap with the help of the Selenium, and we stored in the DB. And then on top of that, we are going to process those our work on top of this data, right? So that is the part is coming out the data extraction. So here the extraction happened from the Flipkart page to our system. This is called data extraction system. Okay, similar can be happen like, let's suppose you are working on some kind of application like PhonePe. So in PhonePe, what are the users are coming, what they are doing on the PhonePe website, they are ultimately developers are storing this information somewhere in the DB, right? So they are storing, and then we have to extract the data from that place to our system so that we can start processing. That is called data extraction. Now coming to the data analysis in the sense of, let's suppose, like, okay, what stats is saying, either it's a p value is more, or it's a skewness in the data set, or we have to do the standardizations, or we have to perform some kind of missing value evaluations. Lot of things is there, right? We have to perform on the data analysis. We have to understand by plotting the graph, and we have to see what the data is saying. Okay, based on that, we have to take the action. Third is the data preparation, means machine only understand the numbers, right? So we have to prepare our data in some way so that we can pass this data to our machine to get trained, right? Fourth is that model training. Model training in the sense of what I'm trying to say. Model training is basically, you got your data, and like we did already, we got the data, we did our EDA, and then we are going to do the model training, right? And then the model training part has been done. So next, model evaluation, whether our model is performing well or not. We're checking the different kind of evaluation metric. If it is a regression kind of model, then we are going to check RMSE. If it is a if it is a what I call like it's classification problem, then we are going to check the confusion matrix, ROC, AUC. Okay, different kind of accuracy, different kind of metrics we are going to check, and based on that, we are going to take a decision whether we should move with this model to the production or not. That is called model evaluation. If the result is not optimal, then we are going to start again from the scratch. That is called again data extraction, data cleanup, data preparation, model retraining with some hyper parameter, different hyper parameter. Then again we'll do the evaluation. This cycle has to move. That's what data scientist job is. Always it's not like a tentative deadline we can put, right? So up to this model evaluation is a kind of continuous cycle until unless you are not reaching the optimal threshold of your accuracy or of your different predefined company metric. Different company having their different metric to evaluate their model. But yes, as of now, we are learning. So we are going with some static metric to go with it, right? Any questions so far till model evaluation? Then we are going with the model. Yeah, please. Correct. Correct. That makes sense. Okay. Sorry, I couldn't get you. Can you pardon, please? Mm-hmm. Yes, model. No, not fourth stage. We'll get to know in the sixth stage. Fifth stage, model evaluation. Okay, I will show you. I'll take one example and I'll try to make a, but first try to understand why we are trying to do, so that it will be, see, this is more about the experience guys who having the 3 to 4 years of experience in the data scientist domain, and they are going to work as an architect. Okay, as an infra architect. Then for them it is very important to understand, and it is important to explain while going for the interview. It's more about the AI architect. That's what always called as a AI ops or ML ops, is something different from the DevOps. Okay, DevOps job is not people used to say, okay, if you know DevOps, then you can work as a MLOps. But my understanding and data scientist understanding is quite different. DevOps cannot fit be as a MLOps. Okay, MLOps work is something different. I can explain. I can make a differentiate between the DevOps and MLOps as well in coming session. But don't worry at all. But just try to stick with the things what I'm trying to explain. But later on, I will explain you why DevOps is role is different as a MLOps. They can work if they can start learning the different metric. They can start working on the MLOps as well. But without knowing those metrics, they cannot be work as a DevOps. Otherwise, they can push anything in the production. Okay, so that's a part. So model, till the model evaluation, we have to do different iterations. That is called model evaluation. Then coming to the part of model validation. Model validation in the sense of which model, though our, let's suppose we did 4 to 5 iterations, right? And out of the 4 to 5 iterations, we are going to validate which model has to be moved. That we already doing with the model evaluation, but model validation in the sense of as soon as we are going to deploy this model into the production, then in which format we have to, 1 minute. Let me switch off my phone, otherwise it deviating my conversation. Okay, now it's fine. So model validation in the sense of, let's suppose you pass your model into the production, okay, and now as soon as you're passing your model into a production, that model expect the data in some format, right? So they want the data in the string format, and you are passing in the form of integer format. Obviously you will get some error. That is called model validation, whether in which format data is coming from the production in the production, and in which format my model is expecting. If my model is expecting integer, then we have to do some kind of type conversion between the production input and model input. Okay, we have to associate some layer. That is called model validation. Seventh stage is coming like model serving. Okay, model serving, let's suppose you train your model, you store your model in your local system, but it won't be work in the production if you are storing in the local system. So we have to come up with some kind of technique how we can serve the model. There is a different technique is associated altogether whenever we are going to speak about, 1 minute, whenever we are going to speak about model serving. So there is a different technique. Okay, if I'm talking about model serving, there is a lot of way people used to do. Some people, number one, some people used to create an API and they are going to do this thing. Second is the SageMaker. SageMaker is the AWS service with which people used to do the serving of their model. Again, every stage having some pros and cons, so don't worry at all. Number one, SageMaker. Number two, SageMaker. Third is people used to serve their model using the TFX. TFX is basically TensorFlow serving algorithms. Okay, so that's also a way with which you can serve your model. Okay, so there's a 3 or 4 stages are there. Now let's talk about something about all the different way of serving the model. Number one, API. If you are going to create an API to serve your model, that's okay. But the biggest problem of creating the API, let's suppose as many people used to work in the US based company, okay, and in US the traffic used to come only in our night time, like Indian night time the traffics are coming, but Indian daytime there is no traffic on the cloud. But if you are going to create an API, then that API will always take the bandwidth, and your cloud is always engage with your work, and your cost will be very high. Means what I'm trying to say, let's suppose you created an API and you expose in some cloud like AWS server, EC2 instance. Okay, you deploy your API into the EC2 instance, and this EC2 instance will run 24/7. Okay, and means though in daytime like 12 hours there is no traffic, but still you are paying for EC2 instance. That's a major drawback in the EC2 instance whenever we are going to deploy our model or serve our model in form of API. So this is the one of the biggest drawback. People nowadays, organization don't prefer this API level, serving the model in form of API. Second, coming to the SageMaker. So now many people, many organizations right now moving towards the serverless deployment. So what do you mean by the serverless deployment? Serverless deployment is seems like on-demand premises. On-demand premises in the sense of whenever the requirement come, you are going to pay for it. Let's suppose you are using my machine for 1 hour, you are going to pay only for 1 hour. But another 23 hours, you are not going to pay. That is called on-demand premises. So SageMaker is the one of the solution which give to serve. There is a multiple solution, Lambda service, lot of things is there, but I'm not going in depth of those things. But yeah, as a data scientist, we are going to deal very frequently to deploy our model as a SageMaker. Okay, so SageMaker is giving the serverless facility and on-demand premises. Okay, on-demand premises in the sense of whenever the hit will come in your system, whenever the hits will come on your system will up and running, and you are going to pay only for that moment. Like let's suppose 1 hour you start your service, only you are going to pay only for 1 hour. Another 23 hours we are not going to pay a single amount of money. That's a benefit of deploying or serving your model as a SageMaker. Okay, so any questions so far in the SageMaker part? Okay, now coming to yeah. Okay, so I'll tell you. See, SageMaker is the dedicated service of AWS. Similarly, every cloud platform having their own service name will be might be something different, but the thing and but the intuitions will be same. Same like SageMaker is a service is provided by the AWS only for the AWS. Let's suppose your cloud is AWS, then you can use this SageMaker. Similarly, if you are going to use the GCP or Azure cloud platform, there is also a serverless deployment process are there, but the name will be different. Okay, so it's not kind of something is a tool dedicated for every platform. Based on the cloud, the name will get changed, but the thing will be same. Okay, now coming to the TFX. TFX is known as the TensorFlow serving technique. It is also not recommendable some instant. Why I'm telling you? I'll tell you. So again, if you are going to use the TFX for your model serving, you are going to use your machine. It's ultimately it is getting deployed in your EC2. Means whenever we are going to do something on EC2, means you are going to take your machine 24/7. Okay, so but the benefit of TFX is that it's going to create a container of your model so that auto scaling and auto downgrading is getting done automatically. What I'm trying to say, let's suppose this TFX again, it's a kind of API, right? So what is trying to do, let's suppose your hit came 5 to 10 hit came, it is serving only one model. Okay, similarly at an instance 5,000 hit came. So what will happen with this TFX, it will auto scale this container 1 or 2 3 4 5 container automatically, and it will serve the request. That's a benefit of using the TFX. Okay, many people are using still, let's suppose Facebook and Netflix, these guys are using TFX, they are not using the SageMaker for their model serving. Benefit is only that like it depend on your demand. Okay, your use case depend on your use case. Let's suppose you are working on US product based company, and in US product hits are only coming on the our night time, then why we should use the TFX? Why not, why we can't go with the SageMaker? Okay, but if you're working on something like Netflix or something like Google, something like Amazon Prime, then there the hits are coming always 24/7. Then in that case, TFX is always fit for deploying the model. Did you understood the way of model serving? Any questions so far, or the different way when to use which kind of techniques, when we should not use which kind of technique? Okay. Any question? Cool. Makes sense to me. Now coming to the okay. Now coming to the our pipeline establishment. Okay. now let's suppose you created your Jupyter notebook and you cannot deploy your Jupyter notebook into the production. To be honest, Jupyter notebook is just for R&D research, just for understanding the how the things is getting work. It is not like that you can deploy the things into the production. That's a one hunch. So what I'm trying to say, so as soon as you're done with your research, the actual term is coming into the deployment. Sorry, into the development. Okay. So there is a different technique to deploy your model into the production. I personally recommend something. Let me take a screenshot and then I can share with you. I downloaded this screenshot from Google only. Let me show you what I'm trying to say. Okay, do let me know if you can see my diagram. Cool, cool, cool. Is it fine now? Still, are you guys seeing over the phone or what? Okay. Okay, cool. No worries. No worries. I will do the zoom once again. Is it fine now? Okay, cool. So see, just try to understand. This is very important. You guys are already done a lot of hell amount of things. But only thing is that we have to do the orchestrate. Orchestrate means order of execution. Order of execution in the sense of, let's suppose you perform X task, then Y, then Z, and like this. So this is called orchestration. So let's understand this diagram is called, this pipeline is called level 0. So still level 1, level 2 is there. 3 levels are there. But at least as a beginner, if you can perform this level 0, then you are in the win-win case. Okay. And I will show you only level 0. But if you have an interest of understanding the level 1 and level 2, I will explain theoretical part. I will explain everything. But in practical, I will show only level 0. Okay. But it depends. Like, let's suppose you have an interest about the AI op. You can join my AI ops class that is dedicated, designed to make complete infrastructure from the scratch. Okay, but here I will show you only level 0. To be honest, it takes time to build this kind of system. So what we are trying to do, just try to understand. Okay, let's design this understanding part. Okay, first thing is that we are going to get the data from any source. Right now, so far we did extraction our data from the CSV file, right? So it can be DB, it can database, it can be CSV file, it can be JSON file, it can be XML file. Source of data can be anything. That's a one thing. As a data scientist, you cannot say my source of data always be a CSV. Okay, your source of data can be anything. Okay, it can be CSV, it can be DB database, or in database also you cannot say it should always be a SQL. It can be NoSQL as well. Okay, so you have to be prepared for everything. Third, you cannot say I need data in form of JSON only. It can be XML as well. So data extraction, first part is coming like data extraction, data analysis. Here you are doing all those things. Okay, second thing, data preparation. Data preparation in the sense of you are going to distribute your data into training and testing, and then you are going to do kind of missing value analysis and filling your missing values and doing your standardizations. A lot of hell amount of things we are doing inside of data preparation. Third part is coming model training. Model training in the sense of what I'm trying to say. Model training is basically you start training like any kind of algorithm, either it's a linear regression, logistic regression, SVM, KNN, whatever algorithm you are using for your use case, you are trying to do R&D here. Model training. Just a minute. Okay, you are doing your model training. Do let me know if you still have any kind of problem or you are not able to understand something at any point of time, or you feel like difficult is going over your head. Then I will try to make you understand, but these are the things we already done in our Jupyter notebook. Now we are going to do associate these things in form of pipeline so that we can perform this task, right? Does it make sense? Yes. So model training we are doing, then we are doing the model evaluation or validation, and this block, this is called manual experiment steps. Okay, these are the things we are doing the manually. But see, as soon as we are adding this arrow, it seems like it is a pipeline. Okay, now we are going to associate this orchestration in order of execution again and again until unless we are not getting a optimal model. Okay, accurate model, I can say. Okay, this is called iterative part. Now we train the model and we register our model, means okay, we train the model and then we got, okay, this model X is performing well compared to the model others model. Then we are going to register that model in some place. Let's suppose right now in you, means in your case, you guys are not using any kind of AWS service, right? So I believe this will be difficult for you guys, but please try to make one account in AWS so that we can show you model registry part as well, so that I can show you, okay, how the registration is getting happen in the cloud. So model registry we are doing, and then as soon as model registration part has been done, then we are going to serve the model into the production and production service. And in the production, number one, in the production, what we are trying, see, till this part means my left section is called ML system, like ML engineer are working on top of. But as soon as we are registering our model, the whatever things has to be done, that part is coming under the DevOps. Okay, that's what I wrote here, ops. Can you see this? Ops. So these are the things is getting done by the operational team. But again, see, only for performing these two things, we cannot hire a dedicated team which is called DevOps. This only two thing, na? ML engineer cannot learn. They can also learn this part, these two things, serving the model and production service, right? They can learn, and that's what in the industry people came up with the new profile which is called ML ops or AI ops, like ML plus operation. If you know these two things, then you can be serve as a ML ops engineer. Okay, and it's a high demand. That's what organization paying more to you as a ML ops. Okay, whenever they are hiring for the ML engineer, obviously ML ops team is getting more package as compared to the ML engineer. That's a one thing, like, because they are serving two profile. Get to know? Any questions so far? Cool. So so see here the major drawback. What are the major drawback it is? Let me show you the drawbacks. Let me show you the drawbacks. Number one, you can see offline data we are collecting, right? So means in production, something new data came and your model is not able to predict the correct result. Then you have to collect the data offline. So drawback, offline data collection. If you are going to collect the data in the offline, means we need someone to observe the production result. That's the biggest problem. Means how you can observe your 24/7 data, right? So that's the biggest problem. That is called offline data collection. Okay, then again you are going to trigger. You can see this second drawback is that pipeline execution is manual. Manual pipeline execution. Pipeline execution means, what I'm trying to say, as soon as you collect the data, then again you are feeling like you have to train your model once again. Then it's a complete manual process. You have to trigger your pipeline manually. Then the complete thing will get happen. That is called manual pipeline execution. Third, evaluation of model is the manual process. Means what I'm trying to say, you retrain your model, you got your result, you did your evaluation, but after evaluation you have to see as a manually, okay, whether my model is performing well or not. That is called manual evaluation process, right? So it can be, means like if you are trying to evaluate your model manually, right? If you are trying to evaluate your model manually, it can be possible like you miss some important metric. Because see, again, the problem is, let's suppose a single person is evaluating their model, then the chances of getting loss of important metric is very less. But what will happen, a different person is going to evaluate your model at a different time, then the chances of missing will be very high. Because see, every person having the different mindset, right? And different mindset, they are thinking in a different way. So that is not possible that every person can think in the same way, right? So model evaluation and validation is a manual process, and then you are going to take a decision whether we should go in the production or not. That's what we used to call it as a model evaluation and validation, and that's what we called it as a manual experiment step. Okay, then we are going to register the model, again doing the same thing. So evaluation, manual evaluation needs to be done. Needs to be done. Okay, and this is our experimental development stage, and this is our stage production, pre-production. That's a thing, that's a we are doing. Okay, any question in this pipeline level 0? Okay, cool. Now let's, okay, now let's talk about level 1. It's quite difficult to make you understand, but yeah, I will try my best to give you the complete complete understanding about level 1, and you guys can understand what is the importance of level 1 and why we should learn. Just a minute. One minute. Mm. Now, hold on. Okay, it is quite difficult, right? But don't worry, it is not difficult at all. Okay. Are you able to see this screen? Level 1. This is called level 1.
Level 1, sir.
This is level 1. Initially, what I showed, it's a level 0. It was level 0. Now I'm trying to explain level 1. Okay, we understood the drawback and limitations of the level 0, right? But still, we didn't develop the level 0, right? But I will try to explain first level 1, and then everything we'll try to understand theoretical part, and then we'll jump into the actual development part. Okay, does make sense? Level 1. So in level 1, what we are trying to do, we are trying to convert few of the things as a automated, okay, whatever drawbacks was coming in the level 0, we are trying to overcome those drawbacks in the level 1, and we'll try to deploy these things into the production. That's a agenda to deploy this level 1. So what we are trying to do, just a minute. One minute. Okay. So in level 0, we miss few of the things. Means like we associated few of the drawbacks. Just a minute. Where is my mouse? Yeah, I got. So first, let's understand how we can overcome the level 0 problems. Okay. So see, number one problem was canary deployment. What is the canary deployment? Canary deployment. Okay. Canary deployment is something, let's suppose, means right now all the organizations are doing the same thing. Canary deployment in the sense of, let's suppose you roll out some feature, new feature, okay, and that feature you are going to test first into the production. So what we can do, we can deploy this new feature only for certain amount of user. They can test this new feature, and so that we can come up with the point whether we should roll out for the 100% user or not. So that is called canary deployment. Means a certain amount of user, we are going to deploy this model for the certain amount of user, means like 20 to 30% user, or whatever industry are got decided, 20 to 30% of user, and then we are going to check the result. Okay, how the process it is, how it is performing. So similarly, in the level 0, what we can do, means how we can overcome the problem, like we can do the canary deployment. Means let's suppose we deploy 2 or 3 model, and these 2 model, one model, new model we deployed, but that new model we are going to only serve only for certain amount of user, and remaining rest of the user will use the same model. Okay, that is called canary deployment. Did you understood what do you mean by the canary deployment? Canary deployment in the sense of what I'm trying to say, rollout for subset of the user, subset of the users. That is called canary deployment. For example, Tesla Autopilot. Okay, Tesla Autopilot deploy only for certain user and certain reason. They didn't deployed yet for the all the reason, right? That's a called a canary deployment, because they don't know the environment of India or other countries, right? So they cannot deploy this autopilot system in all the countries. That's a one of the biggest use case of canary deployment. Second, what I'm trying to say, A/B testing. So I'm just trying to overcome the problem of level 0. I'm not talking about the level 1. Okay, as of now, level 0, just try to solve the problem level 0, then we'll come at the level 1. Okay. Now A/B testing. What is the A/B testing? Just try to understand A/B testing. Right now, all the Facebook promotions, Insta promotions, LinkedIn promotions is getting done with the A/B testing. A/B testing in the sense of, let's suppose I want to promote my course. So where I should promote so that many students can join me. That's the one thing. So what I can do, the promotion can be happen in the 2 way. Like let's suppose I can promote in the LinkedIn, I can promote on the Facebook, I can promote on the Instagram, I can promote on a different source. But the use case from where I put, because wherever you are promoting means you are charging something, right? So where I should put my chart, my my financial, means you can say like where I can put the money so that I will get more revenue. That's the one thing which is called A/B testing. Let's suppose you promote 30% on the Facebook and 70% on the Instagram. Now you're checking, though you are investing 70% on the Instagram, but you are not getting that much of revenue with the Instagram. But you invest 30% only Facebook, but you are getting more revenue with the Facebook. So, so in the future, what we can do, we can switch our this investment. 70% we can switch into the Facebook, and 30% we can invest on the Instagram. So that, let's suppose we invest 30% on the Facebook, that moment revenue was something better than the Instagram. But if, let's suppose, what will happen if we invest 70% on the Facebook and 30% on the Instagram, the revenue always will be better, much better than the Facebook, Instagram. Okay, so that is called A/B testing. Same thing we are going to do with the model as well. So what we are trying to do, let's suppose earlier your model was M1 and now you are going to do with the M2. Okay. Now your new model is M2. What we are trying to do, we are trying to switch our traffic to M1 and M2 both. And now we will check whether M1 is performing better or M2 is performing better here. And if M2 is performing better, then only we can switch our model to, means M2, or else we will keep M1 keep an up and running M1 in the production. That is called A/B testing. Does that make sense? Does it make sense? Okay. Okay. Now coming to the another part, what is called multi-arm bandit. Third is called multi-arm bandit. Okay, which is also people used to call it as a, in AI term, reinforcement learning. Many, it's a huge buzzword nowadays. Once the Chat GPT launch into the production, the buzzword reinforcement learning. That's what we can say like generative model came into the picture. Okay, reinforcement learning is something came from this word which is called multi-arm bandit. Okay, so if if I was talking about the Chat GPT, I got to know few of the question that many people ask me whether if Chat GPT will take the data scientist role. Then my answer is yes, if you know only fit and transform. That's all. Then your job will be not secure. But if you know how to design your infrastructure, because none of the library can design your infrastructure, right? If you know how to design your infrastructure, then you are at the safest zone. So that's what we introduce AI Ops course. I will share the complete course detail, means syllabus, what are things we are going to learn, everything from the scratch, like Linux, Get Basic, very basic things. We will start from the very basic, and then we will start the system designing, architecture designing, DB designing, like DB schema, how you can design your DB schema, everything as an infrastructure level. Though, means like, see, coming future, what I am thinking, what will be the job role? As a data scientist, no one is going to call you. You will be a domain expert. Your job will be as a domain expert. Means what I'm trying to say, I worked many times. My, means like, if you will see my career, I used to work on the finance part much, like, means I used to occupy more time on a finance and real estate. Okay, so I will be domain expert after 2 years or 3 years in this domain. So no one will call me as a data scientist or NLP engineer or AI engineer. Everyone will call me, okay, if we need a real estate experiment expert in some technical or techies, then they can call me. Okay, No one will, because these are the things is getting solved by the anyways some libraries, chat gpt. Why they will pay for that? So I will be served as a domain expert the coming future. So anyone, like whoever working in different domain, like let's suppose someone is working at development, someone is working, because see, anyways, infrastructure cannot be designed by any library. That's the one thing. So whoever will be good knowledge in the infrastructure designing or architect designing or infra setup or DBE schema designing, their job is still safe. Their job is still safe. But who knows only copy pasting, copy the code from the Stack Overflow and paste it into their code base, their job is not secure. Okay, to be honest, their job will be not secure. So for them, and they are not willing to learn as well. So for them, they should know one thing. They should be expert in their domain, whatever domain, whether they are working in e-commerce, they are working in finance, they are working in real estate, they are working in any kind of domain, payment gateway or whatever it is. They should be expert in this domain so that their job will be secure. So going forward, after 2 years, this thing will be happen. To be honest, this things is definitely is going to be happen. No one is going to call you, I need Java expert, I need Python developer, I need like DevOps expert or something, DevOps guy, or this kind of thing. Everyone will be as a domain expert, and many organizations already started doing this thing. Okay, I will take few example. Capgemini. Capgemini is performing in that way. Like they are not going to give any kind of role, backend developer, front-end developer, or something. They are going to give everyone having the same role, which is called consultant engineer. Okay, consultant engineer in the sense of they are domain expert in this in their product. Means Capgemini is a service-based company, right? They used to serve in a different kind of product, like is a IRCTC service or something different kind of service they are going to give. TCS, that's also there is a role. So if you're working on IRCTC, you will be very expert in that domain. Okay, so that's what they used to give the role as a consultant engineer, not as a backend or front end or tester or whatever it is. You will be a domain expert. That's all. So that's a new term, new era will introduce in the world. Okay, so no one is going to call it as their profile, like I'm a data scientist or I'm an AI engineer or I'm something. Everyone will be called as their domain expert. That's all. So that's a term is coming which is called reinforcement learning, so which is called as a multi-arm bandit, which come from the word which is called multi-arm bandit. How it works, number one, what I'm trying to say, let's suppose this is our tradecraft or something. In casino we have seen this kind of machine. So there, every machine having their one lever in the sense of how much load is coming, that is going to measure by this lever. Here also, here also. Okay, so as soon as, let's suppose, at the beginning anyone is coming, they are going to use this machine, anyone is coming. So this lever is measuring the load on this machine. So as soon as this lever is reaching to, lever reading is reaching to some threshold level, then they are migrating this traffic to the machine 2. And similarly, machine 2 lever will check the readings, and if the machine 2 traffic will reach to the threshold, then it will move to the machine 3, and vice versa will go. This is called reinforcement learning. Okay, reinforcement in the sense of, okay, this model is not performing well, uh, then we will move into some different model. That is called multi-arm bandit. Does make sense? So in this way, we can overcome our level 0 problems. Okay, now coming to the level 1 problem. Any question? Cool. Hmm. So let's talk about level 1 here. Okay. Yes. Level 1. Okay. So in the level 1, what are the things we are doing? Same thing. Whatever things we did in the level 0, see, we are doing the data analysis, data validation, data preparation, model training, model evaluation, model validation. Any question in this block? We are doing the same thing, right? Any up to this, there is no question at all. We are doing the same thing in level 1 as well. So that's fine. Now coming to the part which is called feature store. What do you mean by the feature store? Let's talk about the feature store. Okay. So let me talk about the feature store at some instant, and then we can come up with the. See, you can explain this part even we are not working in level 1, but you can at least you should have some this kind of knowledge. Okay, I know we can start working on to develop these things as well. We have this kind of facility level 1, level 2, but we couldn't get a chance to walk around that. But we obviously I'm happy to do this thing. Like this, you can manipulate in the interview. Okay, that's showing that you are interested, you know the things, but you didn't have a hands-on, but still you know something, like you can do that. Obviously level 1 and level 2 people are reaching after the some certain experience, like 5 years, 6 years, 7 years, 10 years. After 10 years people are doing these things, architecture design. Okay, and this design I downloaded from the Google GCP, Google developer platform. Okay, so this is not my design, to be honest. This is the Google design. I just copied and I just understood, and I developed these things in my organization. That's my experience. Based on that, I'm telling you. So feature store. What do you mean by the feature store? First one, number one, central data repository. Data repository means, what do you mean by the central repository? Repository, means let's suppose, for any kind of, let's suppose what I'm trying to say, just try to understand that way. In your team there is a 2 to 3 members are there, okay, and they want to do the experiment. They can take the data, like let's suppose M1, you are M1, member 1, member 2, member 3. Okay, this is the member 3, and now at the end we are checking all the models result. Then we found M3 result is better than remaining all 2. Okay, member 3 result is better than remaining 2. Now the question is, that can be possible, whether they, what kind of model they have been selected, that's a one thing. Second thing might be that member 3 has been selected different data as well, right? So always the source of truth for model evaluation, the data should be centralized repository. No one can pick any kind of data, right? That's the biggest problem of using model evaluation. So whenever doing the evaluation of model, always the input for the all the members should be same. That's what we start storing this feature store. So this will be the central data repository, data repository, me for what, for standard standard definition storage. Definition storage. Okay, access of features for training and serving. Okay, this is called, now we understood a problem, we understood, and solution we gave with the feature store. Okay, now coming to the part. Okay, any question with the feature store? What is the term is feature store? Basically, we are going to associate a centralized repository here, and this centralized repository can be used by any kind of experiment. It will be a source of truth of the data at any stage for any kind of experiment. Does make sense?
So you mean for any project you can use?
Not any project, not any project. Just try to understand. Let's suppose you are doing some kind of classification, or you can say like diabetes prediction you are doing, right? So you pick some 1,000 data and other one pick some another 1,000 set of data. Now, obviously, the result will be different because your input is different, right? So if input will be same and result is different, then is the point to evaluate your model, right? Does it make sense? So that's what input we are going to make it as a constant for any kind of experiment.
Okay.
Got it? Nice. Now, okay. Now coming to the another part, which is called source code. Okay. So see, all the language having their own type of way of serving. If you are working on C++, there is a .c files used to create, right? C file in the sense of like it's an executable file, right? Similarly, if you ever worked on the what we call as a Java or something, people used to create an exe file for the window user. Okay, and with that they are going to serve. Similarly, in Python we are going to create a packaging like PyPy package. As soon as your orchestration has been done, model pipeline has been done, we are going to convert this complete process in the form of pipeline, okay, or library or source code, and we are going to do these things, which is called source code and source repository, and we are going to store this pipeline into some repository. People used to store in the PyPy, but if you are working on organization, you cannot make as a public, right? So you have to make some private repository, and on top of that we are going to store. Then pipeline deployment. This is up to this, I think we were doing only difference this feature store and this source code. Apart from this, nothing special. Any question in this level one? Up to this, no question, right? Now coming to the, now let's understand the part. Okay, as soon as you deploy your model into the, just a minute, as soon as you deploy your model into the production, my handwriting is very bad, I don't know why today, but yeah, it's fine. Just try to understand what I'm trying to say. As soon as you model deployed into production, again you are doing automated pipeline. Means what I'm trying to say, just try to understand here. You train your model, deploy the model, and again what we are trying to do, we are trying to extract the data again in the production, validate the data, data preparation, data model training, model evaluation, model validation, and then we are going to again validate the model, means register the model, train the model, and then we are going to do the CD in the sense of continuous deliver, and then prediction service. And here is the one another term which is called ML metadata. What do you mean by the ML metadata? ML metadata is something like, metadata stands for something like we are going to store all the information what happened at the different stages. Okay, if you ever see like Hive or SQL, in SQL also people used to store the metadata. Means every time developer used to change the schema. Let's suppose in some table schema got changed, like some new feature they are going to associate, so we have to create a new column. Okay, so they have to change the schema. So what was the earlier schema? That has to know, like earlier schema was this and new schema is this. So those every stage information has to be stored somewhere, which is called metadata. So similarly, ML metadata store is basically is going to store every stage information in the centralized repository, and from there we are going to perform all the things, which is called ML metadata store. Does it make sense, guys? I mean, it's like, are you able to understand what I'm trying to say? What is ML metadata? So any moment of time, if you have to switch our model between the previous or newer model or older model, then we can go and switch it with the help of the ML metadata store. That's the important of using ML metadata store. Any question? Hmm. Then what we are trying to do, as soon as you train the model, where is my mouse? Just a minute. As soon as train our model into the CD means continuous deliver, means like deploy, train the model, and model registry we did, and production service, and then again performance monitor. Here we are monitoring our performance, and as soon as performance will get down, again we will trigger this pipeline. Can you see this? Triggering this pipeline. Again will data extraction and validation and training will run, and then again deliver the new model, and we'll do this. This kind of cycle will be keep on going on, so that we can get the result. Any questions so far in this level 1? We are doing same thing, but it's a more pipeline automated thing. Okay, pipeline is very automated. Okay, what are the things is getting stored in ML metadata? It's an important one. Let me do that. Let me make a note of these things. ML metadata storage. See, this is a theoretical concept, is very important. Now you will get to know, okay, what are things has to be done after become a data scientist. This is all about the become the data scientist. What are how we can do? See, everyone used to play with the Jupyter notebook, and they used to call themselves as a. So now I already told you the scenario got changed. Era is getting changed. New era, new technology is coming. So you have to adapt these things. If you're not able to adapt these things, means your job is completely in blind or unsecure. Okay, so you have to adapt system designing, infrastructure setup. Okay, that's always all I all believe. Like if you are still playing with the Jupyter notebook, that can be done by the chat GPT. That can be done is if you'll ask with the chat GPT, hey chat GPT, tell me, write a ML code for the classification of diabetes prediction. It will write code, complete code. But see, that's a important of domain expert. If you are from the medical domain, you can do your own EDA on top of it, right? But if you are not a medical domain, then we have to accept that code. Ultimately, we are doing the same thing earlier, but we were searching from the Stack Overflow, and then we were testing here, but now it's getting done in a one shot, right? So every people having their different opinion regarding for this generative model. I having the one perspective, it is good that chat GPT has been introduced, but at the same time people used to accept the new technology, because machine able to do this, because machine reach your mind till your mind. Now you have to think in the beyond that. You have to think in a different direction. And I already told you, going means coming time, like after 1 year or 2 years, you will be not known with your tech name. Like you will be a software developer engineer, SD 1 2 3, data scientist, AI engineer, okay, DevOps, ML ops. You will not known with this profile. You will be known with your domain expert. Okay, real estate expert it is. Okay, he's a finance expert. Though you have a tech knowledge, that will always add the value, but you will not known with your profile. Now coming to the ML metadata management. ML metadata management. Okay. Uh, I have an open question. I have one open question. From the long time I am speaking and something I am telling. I have an open question. Now just try to understand. What are the information we can store in the metadata? Yeah. What are the information we can store in metadata just based on your experience, based on your knowledge? Just try to answer me this question. Why we should store metadata inside of metadata and why we have to incorporate this metadata in our pipeline? That's a question. Any answer?
Data, I think it is a digital.
Mm-hmm.
You can store most of the data.
Okay. Data you are storing in the feature store, right? Feature store also you are storing the data. Now what is the metadata?
Yeah.
Okay. No worries, no worries. It's okay. That's that you tried. That's fine. But let me. I was expecting some different answer. That might be my bad. Okay. So what I was trying to say. See, in ML cycle, we used to perform different stages. Number one, we have seen data analysis, right? Then number two, EDA. Number three, EDA in the sense of lot of things is coming into the picture. Like you, okay, EDA. Then we are going to do the pre-processing. And after that, we are going to model training. And after that, we are going to do the model evaluation. Okay. So there are the multiple stages we are going to incorporate whenever we are going with the ML life cycle, right? So every stage having some input and some output. So what input this stage expect and what output we are expecting with this stage, and this output will pass to the another stage, and this another stage will pass some output, and the another stage output will perform as an input for the third stage. Like this will go, this is called pipeline, right? So after every stage, what input we passed, it got changed, right? Let's suppose I passed X to the data analysis. I passed X data to the data analysis. It became X dash after performing this data analysis. Now, if I want to recover my X, if I want to reach back to the X, will I able to go? No. So I should store first X to the metadata, right? And then X dash, we reach into the X dash, and this X dash will pass to the EDA, and then EDA will perform some action on X dash, and the output will be X double dash. And this X double, if I want to get the X dash, will I able to do? No. I will store this X dash into the ML metadata. So every stage, after every stage, the output we are going to store the ML metadata, so that at any point of time, let's suppose it will be helpful for your debugging process as well. Let's suppose your pipeline got failed in the pre-processing stage. Means there might be possible the input of the pre-processing stage was not as expected format, right? So at any point of time, we can go to the metadata and we can check what was the format of X double dash which passed to the pre-processing stage, and we can fix that issue, because obviously this X dash is coming to the from the EDA. It's problem with the EDA. So we can fix this and we can roll it out. Does this make sense? Important of ML metadata.
steps is stored in metadata.
Yes, each stage output we are going to store in the metadata. Okay, I'll explain this pipeline. Okay, I'll explain this pipeline in the practical. In feature store, we are storing the data, single source of data, input data. That's all for any kind of experiment.
So, so your
Yes. No, their output we are not storing. That's what, if you can see this diagram, just I will show you the diagram. See, feature store is not connected with this, right? This is connected with the pipeline. ML metadata is connected with the pipeline, and the feature store is not connected with the pipeline. That's what I was trying to say. Does it make sense?
but
Yeah, please. See, now asking the question. See, I'll tell you one thing. Asking the question, it seems like you are learning something. If you're not asking, or if you're listening the Satnarayan Bhagwan Katha, it seems like you are wasting your time, you are wasting my time, you are wasting your effort. So that I don't want, that I don't expect with any kind of student. Always ask the question. So means though the question will be silly, that's fine. I used to address each and every question at any moment. Yeah, please tell me now the question. What was your question? Don't hesitate to ask the question. Yeah. Acha. Acha. Now coming to answer your question as well. See, if we list to, let me make a draw so that I can explain you. If we are going to connect this feature data to the ML metadata, are you talking about this?
yeah,
Okay, so how this feature store will get to know different stage information, because this feature store is not connected with the orchestrated experiment, right? This pipeline is not connected with your feature store, right? So how you can store this output of data validation inside of feature store? That's the first question, right? Hmm. Does Acha, you are trying to complex, make the complex, like the double life cycle you are going to try to do. But yeah, you can try whatever you want, you are saying, but it's the same cycle, single cycle. If we can perform the things, then why we need that? That's the first question. Okay. Okay. Does it answer your question? Now, what are the things we are going to store in the metadata? Let me. Okay. Why we need metadata? So metadata is basically, what is that metadata? Just a minute. Info about each execution step of ML pipeline. Okay, so why it is helpful? Why it is helpful? So first let me write that. Number one, reproducibility. Number two, comparison. Number three, artifact lineage. Number 4, debugging. Debugging. Okay. Okay. Now the question is, which kind of industry should adopt this level 1? So my answer is level 1 will be always helpful for those kind of organization where the retraining process is very frequent. Means today we train the model and tomorrow again we have to train. So it's a kind of manual execution we are doing, evaluation of manual evaluation we are doing. So in order to overcome this problem, why cannot introduce the level 1 so the process can be automated? So it will be helpful for which kind of organization should adopt. Now question is, I was trying. Which kind of organization should adopt this? Number one, it will be very helpful. Number one, it will be very helpful. Let me write a text. Very helpful. That is fine. Number one, it will be very helpful for those organization where retraining of the model is very frequent. Okay. So this kind of approach I always recommend for this kind of organization, not for others. Okay, that makes sense. Yeah, that's the first thing. Now, okay, now coming to the okay, I think let me show you one thing. Here is my mouse. So what it tries to record in every run. That's the first question. Number one, pipeline and component version. Pipeline and component version. Number two, store start time. Start time means like after execution, any pipeline, what are the information we are storing? Start time, end time. Number three, time duration. time duration for completion of each step. For completion of each stage. Okay. Number 3, executor information, like who execute that? Excutor, executor information. Number 4, parameter used or passed to the pipeline. Number 5, each step of the pipeline pipeline, for example, path to prepare data, validation anomaly. Okay, compute stats. Compute stat. Okay. Now 6th is pointer to previous table, pointer to the previous stable model, helpful in case of rollback. Helpful in case of rollback means at any moment of time, if we have to roll back our model to the previous model, then we can do. 7th is model evaluation for testing during execution. Okay, so whenever any kind of pipeline will execute, we are going to store this app the information so that we can use in the further pipeline execution. Any question? Are we good? Okay. Okay, fine. So if there is no question, we are okay with this understanding of pipeline development. Now we can start creation of pipeline, development of pipeline from the scratch. We'll do from the level 0 and we'll try to see how much we can cover and we can take a use case. Okay, so we will start the practical implementation with this. Okay, fine. Thank you. So we'll share the video recordings, everything shortly, but yeah, this is all about for today. We'll catch up tomorrow. Thank you.
Thank you.
Thank you.